National Aeronautics and Space Administration presents Aeronautics and Space Report.
This is the jet-powered X-14, a test aircraft being flown at NASA's Ames Research Center near San Francisco. Although it looks like a conventional airplane, it can take off and land straight up and down. One of the men who flies the X-14 at Ames is test pilot Ron Gertis.
It's different in that it is a VTOL aircraft, and that stands for vertical takeoff and land. This aircraft can take off and land vertically by the thrust provided by two jet engines, and it can hover just like a helicopter can. Now, the thing that makes it different is that it is a research vehicle. We can vary the way this aircraft responds to its controls and thus do some basic research on VTOL control systems. You also might note that we have an open cockpit in this airplane. It's probably one of the few open cockpit jets flying today.
NASA is doing research on vertical takeoff and landing planes like the X-14 to study problems associated with a workable intercity transport system for the future. This model shows what the reusable space shuttle will look like when it begins orbital test flights in 1978. The shuttle will be able to ferry men and equipment into space and then return to Earth, landing like an airplane. A computer program developed by NASA for Project Apollo and now being extensively used in design work for the space shuttle is proving to be a useful tool in other areas of industry and design. It's called nastran, NASA Structural Analysis. A computer programmed with nastran can pinpoint areas of stress on just about anything: bridges, buildings, helicopter blades, even automobiles. A new design can be taken apart, bent, twisted, or broken, all electronically before building the real thing. This information is gathered from a large number of sample points and in less time than conventional testing methods. Car manufacturers are among several industries outside the U.S. space program using nastran. With it, they can detect areas of stress in wheel suspensions and frames. If undetected, these are translated to you, the driver, in the form of bumps and vibrations. Time-consuming shakedown tests become cross-checks rather than an end to themselves because there are no real surprises when the design has been computer analyzed before production begins. Helicopter builders can analyze the design of every part, finding out in advance if a particular piece should be more rigid or flexible to eliminate potential shakes. Nastran is being used to design out vibration problems from electric power-producing steam turbines, increasing their efficiency. Consider this paper industry problem. Huge cutting wheels weighing several tons each reduce a 30-foot log into tiny paper-producing chips in 10 seconds. If a blade gets out of balance from the vibration, it can be extremely dangerous. The structural analysis program helped design out the vibration problem. Nastran is also being used to build better railroad tracks and road beds, and by architects in Chicago to design a new skyscraper. From windproofing skyscrapers to better designed automobiles, NASA Structural Analysis is helping put space technology to work here on Earth.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.